Alright, hi everyone. So this is this lesson 7 word problem that we're going to do. I made this its own video because this is typically the hardest question of the logs that a lot of students tend to struggle on the exam, and I promise you, I think when you look back on this unit, this will probably be the episode for logs that you will look for when you're going over your notes. So I decided to make this its own separate video. So here, for this question, it says the half-life of sodium, I added notes, but I'll get to the notes in a bit. The half-life of sodium 24 is 14.9 hours. The amount of sodium 24 remaining can be represented by the equation A equals PERT. So sodium 24, a lot of students see the 24 and they're like, oh my god, this is a value that I'm going to use. It's not. Like, sodium 24 is just the name of it. It's the same thing as if you saw COVID-19, right? So it's not a value they're going to use, it's just part of the name. So here, suppose that the hospital buys 40 milligrams of a sodium sample of sodium 24. How long will it be until 1 milligram remains? So this question, the bottom part here, is essentially what is going to get you the marks. How long will it be until it only remains? So how long? What variable is that going to be? So that's going to be related to time. So our goal is to figure out what t is equal to. So a lot of students see this question and they're like, oh, we're looking for t. T is time. Oh, look at that. In the first question here, they told us it's 14.9 hours. So t is equal 14.9. It's not. That's a bait. Do not fall for the bait. If this question is going to be worth like 4 marks or 3 marks, it's not going to be that easy. We are going to use the 14.9, but do not say that it's the final answer. So here, we're just going to set up what we know based off what the question told us. But one thing I want to note, the term half-life, you have to know this because on the exam, if they say this term, you cannot ask the person who's proctoring you, the teacher walking around, what it means. We are not allowed to tell you. This is something you have to know for yourself, or a dictionary that you're allowed to bring. You can look it up, but you cannot ask what it means. But here, half-life basically means how long does it take for a substance to get to half of what you started with, basically. So here we have the equation A equals PERT. A is the final amount, P is the initial amount, R is the rate, and T is time in hours. So this is called a double-step equation because we're going to have to solve for more than one variable. And honestly, this question is a lot of students' worst nightmares because they're like, oh my god, I have to solve for more than one variable, and I see there's a whole bunch of actual variables in this equation. But it's not that bad. So here, I draw this line down the middle because we are going to be using this equation more than once. So I'm just going to write the equation on both sides. So A equals PERT. Looks like PERT. And then I'm just going to do the same thing, on the right side. So on the right side here, I'm just going to plug in everything we know. So here, suppose that the hospital buys 40 milligrams of sodium. And how long will it be until only 1 remains? So from the sound of it, we started off with 40, and our goal is to find out how long until it hits 1. So relating these numbers to the variables they gave us, where can we fit those in? So we started off with 40, and look at our variable list, we see P is the initial amount. So initial is the same thing as starting. So that means our P value is going to be 40. So 40. Oh my gosh, I thought my Apple Pencil died, but that's my finger hitting the iPad. 40 equals E, because each is going to stay the same. And here we see, oh my god, sodium 24, where does that go? It doesn't go anywhere, it's part of the name, so ignore that. How long until only 1 milligram remains? So 1 milligram remains. That's our end goal. That's our final value, which is the same thing as final amount. So A is equal to 1. Is there anywhere in this question that told us what R is? No. So we're just going to write R again. How about T? No, it doesn't tell us T because, as the question says, we're looking how long will it take. So they don't give us T either. So the 2 variables we're looking for here is R and T. Now, on the left side, we're going to try to solve for R in order to solve for T, because T is our end goal here. This is what we're looking for our final answer, so that means we're going to solve for that last. So that means on the left side here, we're going to be solving for the other variable we're missing. So what do we do here? So we look at the little description at the start. The half-life of sodium-24 is 14.9 hours. So they actually gave us T in this case. And then here, we're just going to set it up. So for A, our final amount, it says the half-life. So for half-life of our starting amount, and our starting amount is given down here in our description, what you're going to do is you're going to write 40, and you're going to divide this by 2. Because that's our half-life, right? It's going to be equal to P ERT, and then P is the initial amount. So here, our initial amount is what the hospital bought, and the hospital bought us 40. So here, 40, and then that's P, and we have the E again. We don't know what R is, but they told us T, because here the half-life of sodium-24 is 14.9 hours. So here, T is 14.9. So this is a common question where you have to look at everything they give you, and you have to think about where do they go in terms of the context of the question. So there's going to be some information given to you at the start, there's also going to be some information given to you at the bottom of it. So it's a little confusing for students, but you just have to break it down and think logically, what can I sub in? So now, I'm just going to simplify the left side. So 40 divided by 2, because again, in order to get half-life, so 40 divided by 2, is going to take 14.9 hours. So that's why we plugged that in here. So here, in order to get 20, it's going to be this equation. But we want to get R by itself here, right? Because that's the variable we're solving in order to plug it in on the right side. So here, we want to get R the exponent to become a coefficient to solve for. But in order to do that, we have to get it by itself. So here, we want to get it by itself, so we're going to first divide both sides by 40 to get rid of the 40. So now, this is going to turn into 1/2. So 1/2 equals E, and I'm going to write 14.9R because that's just easier for me. 14.9R, and then now we're at a stage where we could write the term ln. So again, we see the letter E here, so you write ln, don't write log. So ln 1.2, 1/2 equals ln E 14.9R, and ln 1/2 equals, so here we put the 14.9R in the front, but remember, what is ln E equal to? It's equal to 1. So this is just ln 1/2 equals 14.9R. And then now, we divide both sides by 14.9 because we want to get R by itself. So here, R is going to be equal to negative 0. And put all your decimals here. Do not round. 465,19945. So again, do not round your decimals here because this is not your final answer. You only round at your final answer. So now we know what R is. So all you're going to do is you're just going to plug R all the way in here. So you can rewrite it and plug that in, but as long as you have this statement somewhere written in your page that you're going to be using this value for R, you don't have to rewrite it, and you could just imply it as you're solving it. So I'm just going to rewrite it just so you see the math, but if you want, you could just technically leave the R in and just save space. But I'm going to rewrite it. So here 1 equals 40 E, and then it's going to be negative 0.046, a whole big number. And I want it by itself, so I'm going to divide both sides by 40, so this is 1 over 40 equals E negative, that's a bracket, negative 0.0465. So now, at this step, we could add ln's to both sides. So here, ln 1 over 40 equals ln E and now we bring our exponent to the front. So it's going to be ln 1 over 40 and a really big exponent. And then here, normally we'd write ln E, but you have to remember ln E is realistically just 1, so I don't want to rewrite it again. So I'm just going to leave it blank, but there's an invisible 1 there. Now we just divide both sides by that giant coefficient. And it's going to be ln 1 over 40 divided by and here t equals 79.297 hours. And that's your final answer. And you're just going to write a statement. So here you're just going to say it takes 79.297 hours to, or not to, but till 1 mg remains. And now you're done. So again, I made this its own separate video because this one's a double-step question, and I think this is probably one where a lot of students will look over for when they're reviewing, and just so it's easier for you guys to find. But that's it for today. Thanks for watching, and I hope this makes sense. There's extra questions for you on the next few pages, and the answer key is also here. But that's it for today. Bye!